Hello, boys and girls. The purpose of making this video is for you to get a better understanding of why we have seasons in the Northern Hemisphere. Now, notice that I said in the Northern Hemisphere because not every place on Earth is going to experience seasons like we do. We live in an area where we're fortunate enough to have four different feeling seasons. We have our winter, spring, summer, and fall, and that's the order that they are throughout the year. Not all places experience the seasons like we do. So, first of all, there's one major reason why we do have seasons on Earth. And if you look at my hand, that tilt of the Earth, the axis being tilted, is the number one reason that we need to know of why the Earth has seasons. Again, the axis is tilted. Okay, my hand is showing that tilt. If the axis were straight up and down, like my hand is now, we would not have the seasons like we feel today. So again, the axis being tilted is the number one and most important reason why we have seasons. Now, with the axis being tilted, we also have to involve number two. The Earth revolves around the sun. That's going to cause the seasons to change throughout the year. Okay, the Earth takes about a year to go around the sun in its revolution, and that's what's going to cause our seasons to change. And since the axis again is tilted, we're going to have seasons either experience getting direct or indirect sunlight. So a different part of the Earth is going to get either direct sunlight or indirect. By different part, I mean different hemisphere, north or south. Remember, we live in the northern hemisphere above the equator. The weird thing is if you live the opposite southern hemisphere, besides being below the equator, you're also going to experience the opposite season that we do. So, for example, if it's summer for us in the northern hemisphere, the southern hemisphere would be experiencing winter. Okay, so right now we're in fall, which means the southern hemisphere would be experiencing spring. So it's opposite for the hemispheres. If you live close to or on the equator, well, that's a different story. We'll talk about it in a moment, but basically you don't feel the seasons as much there. So I want to go through the major two seasons first. And I want to start with winter. So as you can see on this sheet, we have winter here, the top one. And if I go down to the diagram below, so I'm going to circle on this diagram. We're going to start with winter. Okay, we're not in that season right now, but we will be next. And on the diagram, if I go down to went a little too far. First of all, when we look at this diagram, I don't want us to get confused that there are really four Earths. Each of these Earths is representing the start of a season. So we're going to start first over here on the right with the winter solstice, the first day of winter. The solstice just means the first day. If we look, all of these Earths, no matter if it's winter, vernal equinox is the spring, summer solstice is summer, the first day, and autumn equinox is fall. All of these Earths are tilted the same way. Another important thing we need to know is that the tilt does not change. Again, I'm going to say that the tilt does not change. It always stays the same, 23.5 degrees. However, the Earth's position around the sun changes. So if we look at the winter solstice, we live up here in the northern hemisphere. Okay, so this would be winter for us in this position. And down in the south, the southern hemisphere, they'd be having summer. So I'm going to put a little W for winter for us. And down here would be summer for the southern hemisphere. I'll put an SU, okay, for summer. Now, the reason we have winter in this situation is if you look at the tilt, again, it's like my hand is, us living up in the top, the northern hemisphere, we're leaning away from the sun, or we're tilted away. The southern hemisphere is tilted towards the sun. So what that means is when the sun is shining on the Earth, up in the north, we get an indirect hit because we're leaning away. The southern hemisphere gets a direct hit, like straight on, less of an angle. So they kind of get the main concentrated rays of the sun, and we get the leftovers at the top, which means we are getting some sunlight, but it's going to be colder for us in the winter. So that's why it's the winter solstice for the northern hemisphere. Again, in the south, it would be the summer because they're getting that direct sunlight. Okay, so that's winter. If we look at the diagram and we go to the opposite of winter would be summer for us, which would be in the southern hemisphere, that would be their winter. Well, we have to travel about halfway around the sun, and we'll come over to the opposite of winter. I'm going to circle it. This situation here, this would be the northern hemisphere summer. Remember, we live up here. The Earth's tilt has not changed. So this would be summer for us up top, and down below would be winter. Now, what happened now is if you look at the tilt, it's still the same. But in this situation, the northern hemisphere is leaning towards the sun. We're the top leaning towards it. The southern hemisphere is leaning away. It's kind of doing what we were doing before. It's leaning away, which means it's summer for us and it is winter for them. It's actually our first day of summer. Okay. Now, as the Earth moves around the sun, remember it moves counterclockwise, the opposite way a clock would move. So I'm showing some counterclockwise arrows. As it moves around the sun, we go from summer. Our next season would be fall. Okay. And then back to winter, and then back to spring. They kind of go in order. The main seasons are kind of easy to recognize because you're either tilted towards or away from the sun, depending on where you are. But let's say we're in summer, and then after summer, we come to fall. Well, in this situation for fall, it gets a little tricky. In this situation, neither hemisphere is leaning towards the sun. They're both kind of equally getting that direct and indirect sunlight. So if I label this one here, this would be fall for us, because we logically know that fall comes after summer. This would be spring for the South. Well, if we're coming from summer, our next season we cool down. That's fall. Okay, we're cooling down because we're losing a little of direct sunlight and they're gaining a little bit of it, so they're heating up. So this is like an in-between season. Okay, so fall, we're cooling down. They're heating up because the direct sunlight's kind of balanced between the two. It's kind of not direct or indirect based on tilts. After fall, we get colder for winter because we're leaning away. And then if we keep going, eventually we get to spring where it's kind of equal again. And this would be our spring, and this would be their fall. All right. So as long as we can recognize the two major seasons, which are winter and summer, and we know which way the Earth goes, we can then kind of fill in the spring and the fall. So basically, it's based on which hemisphere is tilted towards the sun and getting that direct or indirect sunlight. There are some special days of the year, which we kind of mentioned. We have the winter solstice. That's the first day of winter. It's typically, December 20th, something like that. It's the shortest daylight all year. We don't have a lot of daylight that day. We have a lot of darkness. The spring equinox is the first day of spring, equal day and night, equinox, equal. Summer solstice is our longest daylight of the year. It's the first day of summer. And our fall equinox is the first day of fall, equal day and night. Equinox is equal. That's neither hemisphere gets the direct sunlight. If we look at the Earth, there's one part that's kind of always getting direct sunlight, and that is the equator in the middle. So the equator, if you live anywhere near the equator, you are kind of always warm, no matter what position it is throughout the year. So the equator kind of stays at constant temperature year round if you're anywhere near that red line. That's why if you want to get warmer in the winter, you travel closer to the equator. That's why people in New Jersey will go to like the Caribbean or Florida, because it's closer to that equator in the middle. If you move towards the, North Pole or South Pole, depending on what time of year it is, you might get, you're not necessarily going to get warmer. You could get colder or you could get a little bit warmer, depends. But typically the pole areas, they remain a little colder than the rest. And depending on the way the Earth is tilted, they could have 24 hours of daylight or possibly 24 hours of nighttime, depending on the year. All right, so the big takeaways here are that the seasons, the four of them that we do experience, are caused by the Earth's tilt and whether or not you're getting that indirect or direct sunlight as we revolve around the sun. One thing I definitely don't want us thinking about anymore is that the seasons are caused by the distance from the sun. That is totally not accurate. As a matter of fact, when we're closest to the sun, it's actually winter for the northern hemisphere. which makes no sense at all. You'd figure it to be summer, but it's actually winter. All right, so it's all about that tilt causing that direct or indirect sunlight on a hemisphere. So before we leave the video, I just want to point out that currently, this is kind of where we're at. This is the beginning of fall. Now, fall began September 22nd. So we're actually probably a little past this point, working our way towards winter, but winter will not come until December 20th or 21st, something like that. So we still have a good couple months of fall as the Earth makes its, progression up to the winter solstice in December, when we will be tilted away from the sun and getting that indirect sunlight. And then another 6 months from there, we'll be getting out of school in the summer solstice when we're leaning towards the sun.